Oracle Database at AWS. What is Oracle Database at AWS? After completing this lesson, you will be able to describe what Oracle Database at AWS service is. You'll be able to explain the key benefits of Oracle Database at AWS service. You'll be able to illustrate the key components, the architecture of Oracle Database at AWS. And you'll also be able to compare the database services that are available in Oracle Database at AWS. Let's explore what Oracle Database at AWS is. Oracle Database at AWS is a service that allows Oracle Exadata infrastructure that is managed by Oracle Cloud Infrastructure, or OCI, to run directly inside an AWS data center. In the diagram, we see the following. We see the AWS cloud, which includes a region, which is a geographic location, and that region has an availability zone. It's a grouping of various things. And what it does have inside that availability zone would be my network, the Virtual Private Cloud, or VPC. It contains also an Amazon application server. These servers are connected through the ODB peering, and that ODB peering is to a private network, and that private network is the Oracle Database Network, the ODB network. Let's understand what each one is. The AWS Cloud is the Amazon Web Service, the AWS Cloud. It's a cloud computing platform. The AWS region is a distinct, isolated geographic location with multiple physically separated data center, also known as availability zone. The availability zone is really a physically isolated data center with its own independent power, cooling, and network connectivity. When we speak of the AWS data center, it's a highly secured, specialized physical facility that houses the computing storage, the compute servers, the storage server, and the networking equipment. The VPC, the Virtual Private Cloud, is a logical, isolated virtual network. The AWS ODB network is a private user-created network that connects, or rather in this case, that bridges the Virtual Private Cloud network of Amazon resources with an Oracle Cloud Infrastructure Exadata system. And this is all within an AWS data center. The AWS ADB peering is really an established private network connection that's between the Oracle VPC, the Virtual Private Cloud, and the Oracle Database at AWS network, and that would be the ODB. Within the AWS data center, you have something that you see called the child site. Now, an OCI child site is really a physical data center that is managed by Oracle within the AWS data center. It's a seamless extension of the Oracle Cloud Infrastructure. The site is hosting the Exadata infrastructure that's running the Oracle databases. So in summary, the Oracle Database at AWS service brings the power as well as the performance of an Oracle Exadata infrastructure that is managed by the Oracle Cloud Infrastructure to run directly in an AWS data center, enabling you to be able to run your mission-critical Oracle data load close to your AWS application with seamless management as well as integrations. Let's look at the key benefits of Oracle Database at AWS, which offers a powerful and flexible solution for running Oracle workloads natively within AWS. First, we have simplified migration. Oracle Database at AWS streamlines the process of moving your existing Oracle database to AWS, making migration faster as well as easier. The second is low-level connectivity. You get direct, low-latency connectivity between your application and Oracle databases, ensuring a high performance for your mission-critical workloads. Third, we simplified billing, management, and operation. Billing, resource management, and operational tasks are unified, allowing you to manage everything through similar tools with reduced complexity. And finally, seamless integration. Oracle Database at AWS is designed to integrate smoothly with your AWS environments, workloads, making it so much easier to build, deploy, and scale your solutions. Now, we mentioned about an OCI child site before. Let's explore the OCI child site architecture. OCI is hosted in OCI regions and AD. Let's take a look at each of those acronyms. OCI, or Oracle Cloud Infrastructure, is structured around regions, geographic location, very similar to AWS regions. But we have something called availability domain, AD, very similar to your availability zone. These are isolated data centers within a given OCI regions and is designed to provide fault tolerance and high availability. The next is the Oracle database at AWS. The OCI child site concept is really extending the OCI availability domain within your AWS availability zone. This means that Oracle Exadata infrastructure can be deployed physically within your AWS data center that is still logically managed as part of an OCI region and availability domain. As illustrated on the right, the OCI child site hosting the Exadata infrastructure is located within the AWS data center and availability zone. However, from a logical perspective, it remains part of the OCI region and the OCI availability domain. So, because it has all these capabilities, the residency of the infrastructure is still part of our configuration. Now you can take a look at the OCI child site to be the following. It really gives you the capability to combine the physical proximity and the resources of AWS with the logical management and the capability of Oracle Cloud Infrastructure. This integrated approach allows us to enable the ability for you to run and manage your Oracle databases seamlessly in your AWS environment while still leveraging the power of OCI, our Oracle Cloud Infrastructure. Let's take a look at the architecture of the Exadata infrastructure within AWS. The Exadata infrastructure consists of physical, database, as well as storage servers that is deployed. The database and the storage servers are interconnected using a high-speed, low-latency network fiber, ensuring optimal performance and reliable data transfer. Each of the database server runs one or more virtual machines, or VMs as we refer to them, providing flexible compute resources for different workloads. You can create as well as manage your virtual machine, your VM clusters, in this infrastructure using various methods: your AWS console, command line interface, CLI, or application program interface, that's your API, giving you various options, several options for automating as well as integrating your existing tools. When you're creating your Exadata infrastructure, there are a few things you need to define and set up. You need to define the total number of your database servers, the total number of your storage server, the model of your Exadata system, as well as the availability zone where all these resources will be deployed. In the right, you'll notice in the diagram, it illustrates the setup. You see multiple database servers, each hosting a VM. These are connected through both the client and the backup network, while the storage servers are linked through a dedicated management network. This architecture delivers a high-performance resiliency and flexible management capability for running your Oracle database on AWS. We will talk about many of these independently, the Exadata infrastructure, the database server, as well as the storage server in lessons in this course. Let's take a moment to examine the Oracle Database Network architecture. The ODB network is an isolated network within the AWS that is designed specifically for Exadata deployments. It includes both the client as well as the backup subnet, which are essential for securing and efficient database operations. When you create your Exadata infrastructure, you need to specify the ODB network, as you need the connectivity. This network is mapped directly to the corresponding network in the OCI child site. This will enable seamless communication between AWS as well as the Oracle Cloud infrastructure. The ODB network requires two separate CIDR ranges. And in addition, when you take a look at the subnets, the client subnet is used for the Exadata VM cluster, providing connectivity for database operations. While you do also have another subnet, and that subnet is the backup subnet, and is used to manage database backups of those VM cluster, ensuring not only data protection, but also data recovery. The diagram on the right illustrates how within your AWS region and availability zone, the ODB network contains these dedicated client as well as backup subnet. It basically isolates the Exadata traffic for both the day-to-day access, and that would be for the client, as well as the backup operations, and that would be for the backup subnet. This network design supports secure, high performance, and connectivity in a reliable backup management of the Oracle database deployments that is running on AWS. And since we're on the subject of networking, let's take a look at the ODB peering in the Oracle database architecture. The ODB peering establishes a secure private connection between your AWS Virtual Private Cloud, your VPC, and the Oracle database, the ODB network that contains your Exadata infrastructure. This connection makes it possible for application servers that's running in your VPC, such as your Amazon EC2 instances, to access your Oracle databases that is being hosted on Exadata within your ODB network. You specify the ODB network when you set up your infrastructure, specifically the Exadata infrastructure. This network includes dedicated client as well as backup subnets for an efficient and a secure connectivity. If you wish to enable multiple VPCs to connect to the same ODB network and access the Oracle database at AWS resources, you can leverage AWS transit gateways or even an AWS Cloud WAN for scalable and centralized connectivity. The given diagram demonstrates this relationship. The virtual private cloud contains your application server, and that's securely paired with the Oracle database network, creating a seamless, high-performance path to your application to interact with your Oracle database. So in summary, my ODB peering simplifies the connectivity between the AWS application environments and the Oracle Exadata infrastructure, thus supporting a flexible, high performance, and secure database access. Now, speaking of databases, let's take a moment to compare two key database services that are available with the Oracle database at AWS. The two databases would be the Oracle Exadata database service, as well as the Oracle Autonomous database service. The Exadata database service offers a fully managed and dedicated infrastructure with operational monitoring that is handled by you, the customer. In contrast, the Autonomous database is fully managed by Oracle, taking care of all the operational monitoring. Looking at scalability, Exadata provides very high scalability, though resources such as disk and compute must be sized manually. Where in the Autonomous database, it offers high scalability through automatic elastic scaling. When we speak of performance, both services deliver strong results. Exadata offers ultra-low latency and Exadata level performance, while the Autonomous database delivers optimal performance with automation. When we consider migration, both services provide high migration capability. Exadata offers full compatibility, and the Autonomous database includes a robust set of migration tools. When it comes to management, Exadata requires manual management and administration, and that's really, in a way, to provide you the ability to customize it in the manner you desire, making it meet your very specific business needs, especially your database needs. In contrast, the Autonomous database is fully managed by Oracle, including automated administration tasks, optimal self-tuning features, to further reduce any management overhead. When we speak of the feature sets, the Exadata delivers a full suite of Oracle features, including the RAC application cluster, or the Real Application Cluster RAC, whereas the Autonomous offers a complete feature set, but specifically that is designed for optimized autonomous operations. Finally, when we speak of integration for both of the services integrates seamlessly with AWS service, such as your EC2, your network, the VPC, your policies, the identity access management, your AIM, the monitoring with your CloudWatch, and of course, your storage, your SC, ensuring a consistent experience within your AWS ecosystem. In summary, when you take a look at the two database services, the Exadata database service is ideal for customers seeking dedicated infrastructure with granular control, whereas the Oracle Autonomous database is designed for those that desire fully automated cloud database experience. In this lesson, you learn how to describe what is an Oracle database at AWS services. You explain the key benefits of Oracle database at AWS service. You're able to illustrate the key components, the architecture of Oracle database at AWS, and you're able to compare the two database services that are available to Oracle database at AWS. Thank you for watching. Oracle Database at AWS. Onboard prerequisites for Oracle Database at AWS. Welcome to this lesson on the prerequisite resources for onboarding Oracle at AWS. After completing this lesson, you should be able to describe what onboarding is. You'll also be able to describe what the prerequisite resources for onboarding are. Onboarding Oracle database at AWS is the process of setting up and configuring an AWS environment to utilize Oracle database services running in an Oracle Cloud infrastructure, an OCI Exadata hardware, and it's running in an Amazon Web Service, and that would be the AWS data centers. Now, before we can set up and begin onboarding, certain items needs to be in place before we begin our onboarding. Let's take a look at those items together. The first one would be the AWS account. The AWS account is where resources will be provisioned and managed. Now, remember, this is not the master or the management billing account, so make sure you do not use this account when you are trying to address your private offer, as if that's the case, the private offer will need to be reinitiated. The other thing that needs to be in place before you start your onboarding would be the IAM policies, and also the consideration of the AWS service control policies, the SCPs. Now, when we speak of the AWS Identity and Access Management, the IAM policies, they manage specific permissions for users as well as roles within an AWS account, while the service control policies, the SCP, is really a higher level policy that is set to maximize or define the maximum permission boundaries for accounts. Now, those accounts are really on an organizational level. It's not really on an individual account level. Not even the IAM policy can override permission boundaries that is set by the SCP. So the simplest way to remember this is the IAM grants permission, whereas the SCP restricts or filter permissions and applying it at an organizational level versus at an individual account level. Now, the third thing that needs to be in place before you begin onboarding would be your Oracle account. We refer to that as our Oracle, our OCI tenancy. The OCI tenancy is an Oracle Cloud account. It can be a new account or an existing account that can be linked to the AWS account as part of onboarding. This is your primary account in Oracle. It is the root for all your cloud resources within OCI. Let's have a better understanding of the AWS account. The AWS account is where you create and manage your AWS resources in the account. The account also provides identity management capabilities for access as well as billing. The cloud resources and the data is contained in this AWS account. The account acts as an identity as well as an access management for isolation boundary. When we speak of the AWS account, it really has two primary functions. The first one would be a security boundary, as we mentioned. An AWS account is the basic security boundary for your AWS resources. The resources are created in this account and is available to users who have credentials for the account. Examples of security resources for users would be your user itself, the roles and the policies. The identities have credentials to sign into the account, a way to authenticate to AWS. They also have policies that specify what a user can do, and that would be the authorization with the resources in the account. The other functionality of an AWS account would be a resource container. An AWS account is the basic container for all the AWS resources created by an AWS user. Every resource has a unique identifier and is identified by an Amazon resource name, and that would be ARN. It includes the account ID of the account that contains that resource. So when we speak of the AWS user for the Oracle database at AWS, it has the ability to do several things. One of it would be to request as well as accept the offer for Oracle database at AWS. Another would be the ability to create resources for Oracle database at AWS. The resources would be like your Exadata infrastructure, the ODB, the Oracle Database Network. In addition, it also has the ability to be granted access by owner to specific resources. So an AWS account, which owns certain resources, can give permission via policies to other AWS accounts. This way, only to allow access to specific resources that is owned by account that is created, rather than resources to all the resources in that account. In addition, when you think of the AWS account, also think of roles. The roles, the identity and access management roles, are used to grant permissions. As mentioned, we use roles to grant permission to workloads, like applications running on your Amazon EC2 instances. It enables federated access for workloads. It has the ability to provide identities to use corporate credentials, allowing access between different AWS accounts, and facilitates the communication between various AWS services. There are two types of roles in AWS for Oracle Database. The first one would be the AWS Identity Access Management. These are the AIM roles, and they're basically providing permission for the AWS services or the users to interact with the resources, and that includes the Oracle Database. The other would be the Oracle Database roles. Now, this is a role that has specific sets of privileges for the database user. So this is a way to provide a role in order to perform specific actions like other AWS services to be able to call and manage the Oracle database environment. Going back to policies, policies is really a document that defines who, either a user or a group, can access what resources and how that action may be performed. When we speak of policies, we have the AWS IAM policy. We spoke of that, and that really would be the way to define and grant specific permissions to users, groups, and roles to access your AWS resources. We also mentioned about the AWS Service Control Policy, the SCP. Now remember, this is the one that defines the maximum allowable permission for what accounts are able to do within an organization. And we also have our Oracle AIM policy, and those are distinct to Oracle Cloud Infrastructure. This defines the access to Oracle resources, the OCI resources. And just like the AWS policy, it defines who can perform what actions within a tenancy, with a focus on the least privilege. So we basically always have the least privilege that we grant to user. It's very similar to the fundamental purpose of your AWS AIM policies. With the AWS policies for Oracle, there are several things that one can do. So here's an example of one. With my Amazon DB ODB service role, it allows me to access my Oracle database. So with this, the AWS managed policy will then be able to attach to a service link role. It grants the database, Oracle database AWS user the necessary permission to perform various actions, such as managing the infrastructure, the Exadata infrastructure, managing the VM, the virtual machine clusters, and other related resources within the service. Now, there are other policies beyond just the database for the user. You can also consider policies for like the AWS Marketplace. This will be a way to create as well as accept the purchase agreement, the ability to create the ODB, the Oracle Database Network, as well as the ability to establish the connection to communication, the ODB network peering. So examples of various different policies. Onboarding tasks by AWS users. Many of the tasks performed during the Oracle database at AWS onboarding require permissions on either the AWS as well as the OCI cloud. An AWS administrator will need to be able to be assigned the policies with permission to perform the tasks required to request a private offer as well as purchase the offer. Whereas an OCI administrator, and that would view the Oracle, needs to have the assigned privileges in the policy with permission to perform tasks that is required to perform the linking of the OCI account. This is the process of establishing connection between an AWS account and an OCI tenancy, so as to run the Oracle database services from within the AWS account. So it's important to understand, even though both of these users are really AWS user, they both have different functionality. One is the AWS administrator that will then obtain the privileges to get the private offer as well as the purchase. But once the purchase has been finalized and completed, you need an AWS user that will serve as an OCI administrator. And this will be that link between AWS and Oracle OCI. Now let's take a minute to see the Oracle account. This is the OCI tenancy account. Now, the OCI tenancy account is linked to the AWS account as part of the onboarding. But I want to spend a few minutes to share with you how they have very similarities in terms of its function, very similar to OCS account. So when we take a look at the OCS and the AWS account, let's see the following. Like other accounts, for example, your AWS account is an account within the Oracle Cloud infrastructure. A user is basically an individual that needs required access to certain resources, be it OCI resources in our case. That user belongs to a group. So a group is really a collection of users that shares the same access requirement to resources. Groups are used to simplify the management of permission and access control. Now, there's one thing to remember. Permission through a policy is granted to a group, not to an individual. So I always remind myself, when you grant a policy in Oracle, it is always granted to a group, not to an individual user. So you have a user that has very specific needs, very specific privileges. You may end up needing to create a group of just one user, as illustrated with my user number 2. The other thing to also remember is the following. The policy, now, just like AWS, Oracle has policy. It's the same thing. An Oracle policy is a document that defines who, in this case, the group, a user of one group or many users to a group can have access to OCI resources and what they may do. The policy, as mentioned, is always assigned to a group, never to an individual user. So even if the group is one user. But I also want to draw your attention to one unique thing, a compartment. Now, remember, AWS has that. Its AWS account has that capability of grouping all the resources into a grouping, in this case, your account. Well, Oracle has a very more unique capability of that. We have compartments. Now, the difference is compartments are really hierarchical in Oracle. An Oracle compartment is really a logical container that is used to organize as well as isolate cloud resources. In addition, it's used to manage access as well as the ability to measure usage and billing, very similar to what AWS does. We'll discuss this a little bit more as we get into the various steps of how to define each of the steps through the onboarding. To summarize, in this lesson, you've learned how to describe what is onboarding and what are the prerequisite resources for onboarding. Thanks for watching. Oracle database at AWS. Requesting purchase offer for Oracle database at AWS. After completing this lesson, you should be able to describe what a request offer for Oracle database at AWS is. You'll be able to explain the process flow for the private offer for the Oracle database at AWS and you'll be able to explain the detailed information when viewing the private offer. Onboarding to Oracle database at AWS refers to the initial setup and configuration process required to start using the Oracle database at AWS service to run the Oracle databases in an AWS environment under Oracle's management. All that starts with a request for offer. When we speak about request offer, it really refers to the initializing of the negotiation with Oracle for a custom contract, including the pricing and terms, and defining the using of their services within the AWS environment. This process involves engaging with an Oracle sales team to tailor a contract based on factors like the length of the contract, the spending commitments. After that, after the negotiation, Oracle will create a private offer within the AWS marketplace, which the customer then accepts the final purchase. So as mentioned, it all starts with, at AWS, the marketplace, a request for the private offer. From there, we see the following. With the private offer, which is a custom agreement for the purchase of the AWS database at AWS, it has the following workflow. It starts with contacting the Oracle sales. You're engaged with the Oracle sales team to discuss the specific needs for Oracle database at AWS. You negotiate the contract outlining the details of the cost as well as the number of Exadata hardware deployments. Then we will create that private offering. Oracle then creates that a personalized private offer for your organization within the AWS marketplace. This will then specify the agreed upon pricing and the terms of the contract. Then you, the customer, will then access the AWS Management Console, locate the private offer, review its detail, and then accept the terms to purchase the Oracle database at AWS. Once that's done, Oracle will then inform you the account that you need to create, and from there, you will then initiate the onboarding, and that would be the creation and management of the Oracle database resources within the AWS. So how do you request a private offer? It starts with your AWS administrator, who will then perform the task of requesting the private offer as well as accepting. To request a private offer, you would then click on the AWS navigation menu. From there, you select the database. Once you select database, you will see under database, you have option for Oracle database at AWS. Once you select that, the console page loads, and then you will see the following. You will then click on the product page for Oracle database at AWS, a request for private offer. Once you have that in place, then the Oracle sales team will work with you. From there, you have a drop-down for the private offer, and it'll ask you what would be your region that you wish to run your Oracle database at AWS. This should be a region that is closest to your geographic location. Then we'll ask you for information about you, your name and contact information. And when you provide all that information, you will then say, click on Request Information. The sales team will then reach out to you, contact you, and your specific needs and requirements will be discussed, including the desire for the Oracle database at AWS offering. And this will then be deciding the type of databases you will create, the Exadatabase, the autonomous database, and how it's relevant in your AWS regions. You'll negotiate the pricing. You'll negotiate under other relevant details. Once agreement is reached with Oracle, a private offer will be placed in the AWS marketplace. This will then reflect the negotiated terms that was agreed upon. Once that's done, after you engage with the Oracle sales and negotiated a contract, you can view that private offer that was created by Oracle in your AWS marketplace. Go and view the private offer. You do that by opening the AWS console navigation menu and select Database and select Oracle Database at AWS as you did before. The console will then load the product page for the Oracle Database at AWS. On the product page, you notice the private offer. You will then view the private offer. And from there, the private offer, you will then see a list of offers, assuming this is the one that we are referring to. Once you click on the link of that offer, you'll see the ID. In this case, you'll see an example of the link offer hyphen A4, so on. Click on that link, and that'll bring you to the following: the purchase of the private offer. Review the details of your offer. Review the financial details that's confirmed and agreed upon. In addition, you may notice I'm pointing to view financial details, but I want to draw your attention to something above it. You notice on the top is a green box, and it shows your purchase for the Oracle database at AWS is completed. You can click on setting up your account after everything is done, after accepting the purchase and all the link is done. But I want to draw your attention. The next thing is to prepare to create all those accounts, making sure you have your AWS account. But now also, if you don't have an Oracle account, this is when you will prepare to create one. And here, continuing after viewing the financial detail, the offer detail, it's a private offer. Okay? And from there, you will see the following. Now, all we want to do is commit to that offer. So click the commit radio button in the available units, and this is your way to accept the offer. And just click accept. From here, you will see once that's done, going back to the AWS Marketplace, click on the private offers. And from there, you'll see accepted offers. And this way, now you not only see the offer ID that you saw before, now you see the product. In this case, the product would be the Oracle database at AWS and the active agreement and a link to that agreement, the contract. Congratulations, you accepted your purchase of Oracle database at AWS. In this lesson, you learn how to describe what a request offer for Oracle database at AWS is. You're able to explain the process flow for a private offer for Oracle database at AWS. And you're able to explain the detailed information of what you see when viewing the private offer. Thank you for watching. Oracle database at AWS. Link to Oracle database at AWS. After completing this lesson, you should be able to describe what an Oracle Cloud account for Oracle database at AWS is. You'll be able to add an Oracle Cloud account to your database at AWS subscription. You'll be able to verify the resources for the database at AWS subscription, as well as describe what a dashboard for the database at AWS is. Linking to Oracle database at AWS. Linking is the process of associating an Oracle account, also called an OCI tenancy, with the Oracle database at AWS subscription. The Oracle Cloud account may be a new account or an existing one. After you purchase an offer for Oracle database at AWS and accept the offer in the AWS Marketplace, Oracle will send an email with the subject line, "Action Required. Welcome to new Oracle Cloud Service subscription." Use the link and the information in the email to activate your Oracle database at AWS. Here you see an example, an option. You may create a new cloud account or use your existing cloud account. Let's go through how to create a new cloud account. Selecting that link, selecting that option, it will then bring you to the following. You will then enter in information about your new cloud account. You will then provide information about you. Note the person creating the new OCI account creates the administrator user for the account, and this user has the required permission for the database at AWS onboarding. The OCI account in the dialog window open. You select the customer type, personal or business, provide information about you, your contact information, your home region from the dropdown, and make sure you select a region that's closest to your location. Now, you may notice a checkbox, and the checkbox is used for you to acknowledge that you understand that the OCI home region cannot be changed. So the region that you select as your home, you want to make sure is the one not of where your geographic location is the closest to a region that is available to you. From there, you then just create the cloud account. Oracle will then send you an email with the subject line, "Your services are ready." When the account creation and the linking operation to account, you can now use that account to then link your OCI account with your AWS account. Another option would be that you already have an Oracle account, and you may then use that existing account to then link to your AWS account for the onboarding. In this case, we'll ask you to log into your Oracle account. So here, when you click on Add an existing account, it will then continue, and you will then be requested to log in with your OCI credentials. Once you log into your Oracle account, regardless if it's a new account or an existing Oracle account, you will see the app subscription page appear. From here, you may notice that you have the following. You can then click on Add Subscription to activate your subscription. Now, I draw your attention to the name in what you see under the column Subscription. You will see something by the naming convention of Oracle DB at AWS. And it really stands for that. It's Oracle Database at AWS. You will have your subscription ID and a description of it. You want to then click and read that information and confirm that it is correct. Here you see continuing, thanks for adding your subscription. We want you to learn more about your subscription, your role, and once you're done, you just want to click close. Oracle will then email you when the subscription activation is completed. You want to wait for the linking process to complete and receive the activation email before you proceed with all this. But we want to show you what you will be doing. Now, once your subscription has been activated, you want to make sure everything's in place for you to use it. You want to verify your subscription. So after you link your OCI account, you can confirm that your database at AWS activation by checking the OCI console. To verify subscription mapping, go to the OCI console, and you may notice in the OCI console, you see subscription mapping. Click on that link, and it'll bring you to your subscription mapping. And what it will show you is your subscription ID followed by the subscription type, in this case, the Oracle database at AWS. From there, if you click on that link, you'll then view more details about your subscription. Now, I want to draw your attention. You may always notice there's the number followed by the subscription name. So it'll always map to something, a number, and the Oracle database at AWS. Click on that, and it'll bring in this information. So here you see the number followed by some X, and here it'll show you your subscription mapping. So by clicking on that link under subscription ID, it'll bring you to the detail of that subscription mapping. And what you want to make sure is not only the subscription ID, but of course this subscription type. And here you can verify and validate that it was mapped on that particular date. It'll show you more information about your subscription, your start date, your end date, and so on. But now we want to make sure after you verified your subscription, you want to make sure that you have all the proper resources that you need for your usage of database at AWS. You want to verify a few things. The first thing we want to verify would be your limits, quota, and usage in your Oracle account. How you do that is to go to the navigation, and from navigation, go to governance and administration. And from there, you look at your limits, quota, and usage. Now, it's important to understand that you know what your limits, quota, and usage are because the service limits in OCI directly impacts the ability to deploy your Oracle database resources in AWS. So knowing the limits ensures provisions, or rather that provisioning will be successful in AWS. And this will be necessary when you provision, create your Exadata infrastructure, your Exadata, as well as your autonomous VM clusters, the pluggable databases, the databases for AWS. So you want to make sure that all this will be successful without any resource constraint. Once you click on that link, the limits, quota, and usage, it'll bring you to the following page. Now, your tenancy is really an Oracle account, so it really shows many things. So I want to focus on the way to filter to what is applicable for you. Under Services, you select Database, because we are making sure that you have the proper quota for creating a database. Now, the scope, you want to pick the available domain. Now, if you don't know the AD, which is available domain, it's very similar to availability zone in AWS in terms of conceptual. So you can check one of the three in that you see listed here that is relevant to your region. Next, you will see the subscription. This subscription should always have, as you saw before, some number, followed by X, and of course, the subscription name that always ends in Oracle Database at AWS. Now, what's important would be the compartment. Now, remember, we share with each other, a compartment is really a grouping of your Oracle resources in Oracle ACI. Confirm your tenancy has the resources. You want to take a look at the compartment and the compartment name. And from there, you see the following. You may see the resource limit in terms of your database. And here you see an example of the following. I show two databases. They're Exadata, and these are the database servers. These are the physical virtual machines that will then house your Oracle database. In this case, the Oracle database at AWS. You see I have two database server for the first one, and I have three for the second one. So my service limit for the number of, or I should say, the amount of database server would be the following. The diagram shows for my first one, there are two. And for the second one, there are three. And so for my Exadata on one version, I have a count of 126 core. And for the second one is a storage server. So two separate things. I have two database servers and three storage server for my account. So this gives you a good idea when you start creating your Oracle environment, your Exadata infrastructure, your virtual machines, your VM cluster, how many you may create depends on what your agreed contract is. And this way you do see what are your limits as well as your quota. Continuing, after knowing your service for your database, the scope, the subscription, and the compartment, and verifying the database server and the storage server, you can then take a look at the compartment as we share together. Very similar, going to the navigation menu, select Identity and Security. From there, go to Compartments, and it'll show you the following. Always take a form of what you saw before, but I want to draw your attention to the compartment detail. Specifically, I want to draw your attention to the compartment name. You have a compartment name that starts with multi-cloud link underscore AWS. And under there is a listing of compartments. I draw your attention also, besides the name of that compartment, you see something called child compartments. A child compartment is a compartment that exists within another compartment, the parent compartment. It's a nested structure where compartments are organized hierarchically, allowing for more granular control over the resources within your OCI. When you see the child compartment, you may notice the naming convention. It will always end with something called resource anchor. And this lets you know that you have a compartment in your cloud account in Oracle. This is the compartment where we will create your Exadata infrastructure, your virtual machine, your cluster, as well as the databases within the virtual machines. And that brings us to the dashboard. The Oracle Database at AWS dashboard is a user interface within the AWS Management Console. It allows you to, using this dashboard, to get to the services, provision and manage your Oracle Database services, specifically, as I mentioned, your Exadata infrastructure. And that's all within your AWS environment. This gives you the capability to facilitate creation of all the resources you need, the creation of your ODB network, the infrastructure, the cluster, the peering connection, and this will allow the connection between your Oracle as well as AWS. It's a simplified way to access and manage all your Oracle databases that's hosted in OCI, but accessible through your AWS environment. All you need to do in AWS is to navigate to Oracle Database at AWS product page and search for Oracle Database at AWS and just click on Dashboard. And that will then navigate you to the Oracle Database at AWS Dashboard. In this lesson, you learn how to describe what an Oracle Cloud account for Oracle Database at AWS is. You learn how to add an Oracle account to your AWS subscription, and that would be either an existing account or creating a new account. You learn how to see what are the resources that's associated with your database at AWS subscription, and you learn what a dashboard is specifically for the database at AWS and how to access it. Thank you for watching. Oracle Database at AWS. Getting started with Oracle Database at AWS. Welcome to the lesson on getting started with Oracle Database at AWS. We will start first on understanding the required resources when using Oracle Database at AWS. After completing this lesson, you'll be able to describe the required resources for Oracle Database at AWS. You'll be able to describe what an Oracle Database Network, ODB network, is. You'll be able to describe what Oracle Exadata infrastructure is. You'll be able to describe what Oracle VM, virtual machine clusters, are. You'll be able to describe what Oracle Database services are available for the Oracle Database at AWS. And you'll also be able to describe what is the Oracle Database peering connection. Resources for Oracle Database at AWS. There are 5 resources that are required for Oracle Database at AWS. That would be the Oracle Database Network, the Oracle Infrastructure, the Exadata infrastructure, the Oracle Virtual Machine clusters, the Oracle Databases, as well as the Oracle Database peering connection. Now, we'll go into the Oracle database network, the infrastructure, and the VM cluster, as well as the peering. But the specific databases, what are the Oracle database services that are available for Oracle database at AWS, will be in other lessons. First, the Oracle Database Network, the ODB network. Now, the ODB network is really a private, isolated network within the AWS availability zone that houses the Oracle Exadata infrastructure. It connects the Oracle database infrastructure to the AWS environment, enables communication between applications in AWS, as well as the Oracle databases that is hosted in OCI. The Oracle database at AWS APIs can be used to provision the ODB network. The network infrastructure is specifically designed to provide connectivity for the Oracle database services within the cloud environment. This is a private and secure connection between AWS and Oracle OCI, where the Exadata infrastructure as well as the database services reside. AWS manages the ODB network. An administrator will set up the ODB peering connection to connect the Amazon VPC to the ODB network. Oracle Exadata infrastructure for the Oracle database at AWS. Before we go into the detail, I want to sort of take a minute so we can all have a better understanding of what an Oracle Exadata infrastructure is compared to the Exadata VM cluster and the Exadata database. When we look at our illustration here, and I'm going to box off things so you can see it, I have a box around the entire thing. That would be our Oracle infrastructure. The Oracle infrastructure is really a physical hardware, and it's also the software of the Exadata system. It includes two things. It includes the database server, and that would be all the database servers, as well as the storage servers. So those are two separate things. Basically provides the resources for running the cluster as well as the databases. The next thing I want to share with you, besides the infrastructure, would be the clusters themselves. So let's take one of the clusters. Here you see in my Exadata, that would be the big box I created a moment ago, but now I'm only boxing off the 5 clusters, and they're all different color coded. So you see I have a purple cluster and a light blue cluster and so on. But I want to focus on one. And here you can see the following. For my clusters, the purple one, you notice that of all the database servers, I have a clusters on the following servers. So a cluster is really a collection of virtual machines running on the Exadata infrastructure. It provides a dedicated environment for running the Oracle databases. The virtual machine, the VM clusters, are connected to the infrastructure via the network configuration. You can manage and access the clusters through the console, the command line interface, or APIs. As I mentioned, I'm showing you different types of clusters that you may or may not have. I want to make an emphasis. This is not intended that they all exist in one infrastructure, and that would be the Exadata. Because specifically, especially for an autonomous cluster, you may only have one autonomous cluster in one infrastructure. But for the purpose of our drawing, so I can fit it all in one slide, I wanted to emphasize the infrastructure, as mentioned, which is really the hardware and the software of the system. And on that system, or in that system, I have the cluster, and the clusters are my 4 that I have color-coded. And I wanted to share within each of the cluster would be my databases. And you can see I have a virtual cluster for one of my database, my Exadata, and so on. Continuing, as mentioned, now that I have the databases, you can see my purple cluster, that would be one VM cluster, consists of 3 Exadata databases. My light blue cluster, since I'm identifying them by color, has 2 Exadata, Okay. And my green cluster has 6 autonomous databases, and they can be transaction processing databases, as well as the yellow cluster, or it's like beige color, will have 6 autonomous databases, and they may be for data warehouse. One of the things I wanted you to get from this is the ability of grouping the specific type of databases, and I use the autonomous for transaction processing versus the data warehouse to be in separate cluster. You want similar type of databases and how they will work to be in one cluster. Now that you have an idea of the infrastructure, now let's take a step back and look at the big picture and how it exists in my AWS environment. My Exadata infrastructure resides in my availability zone, so in my AWS data center, and that is in my availability zone. As mentioned, my infrastructure is really a dedicated hardware, in this case, the database servers as well as storage servers, and it's also software. It runs the Oracle Exadata database as well as the autonomous databases in my AWS environment. It's a cloud service that provides the same high performance and availability and security as the traditional Exadata deployment, but now it's integrated with AWS service. It basically leverages the benefit of Exadata for their Oracle database while taking advantage of running it in an AWS environment. You communicate with your Oracle environment through the ODB, the Oracle Database Network, and with the communication of the ODB peering. Now, going back to the next thing, now that we spoke of the Exadata infrastructure, let's talk about your clusters. What I want to share with you here is the following, and as a reminder, when we speak of an VM cluster, reminder, it's really a group of virtual machine, and that is provision created in my Oracle Exadata infrastructure. This way, it provides an isolation and is an easier way to manage resources and configuration that are very specific to the needs of the databases as well as the application. Now, what I want to illustrate here is not in one Exadata, especially if it's autonomous, in one Exadata infrastructure, you have all of this, but I wanted to use this as an illustration. What you see here is different VM clusters, and for each, it's really representing a similarity of its needs. Each VM cluster can be configured with specific resources, like having specific amount of CPU and memory and storage for the applications or the databases. And in our example here, we want to have more storage for analytics. But I may also wish to have more compute capabilities for online transaction processing with a grouping, a cluster for all my autonomous databases. So I would have, in this example, an autonomous VM cluster. And on the bottom, I can also have an autonomous cluster for my environment, my cluster for autonomous databases. But in this case, I don't want a lot of computing. I want to have a balance of compute and storage. So here you see 3 separate examples of creating a cluster, which is really a grouping of the machines, virtual machines, for databases that may have very similar needs. So this way you can balance and manage them much easier. Now we'll talk about this in another lesson on a very high level. The 2 database services that are available for your Oracle database at AWS would be your autonomous database as well as your Exadata database service. Now, they both, the autonomous database as well as the Exadata, really runs on a dedicated Exadata infrastructure. Now, the primary differences between the service is really the management model. The autonomous is fully managed by Oracle, while the Exadata provides flexibility for you to have a the ability to customize your database environment while still having the infrastructure be managed by Oracle. As mentioned, more details of the Exadata databases as well as the autonomous databases in another lesson. The last resource that is required for Oracle database at AWS is ODB peering. An ODB peering connection allows setting up a peering connection between ODB network and a VPC, which enables your AWS applications to connect to your Oracle databases. The ODB peering is a user-created network that enables that traffic to be routed privately between your Amazon network and the ODB network. It is a one-to-one relationship between VPC and the ODB network. You can peer the ODB network in one account and click on the VPC in another. So this allows using the AWS Resource Access Manager, a service to allow you to then share your AWS resources with other AWS resources. In this lesson, you learn to describe what is ODB network,